Pixel processor arrays, or PPAs, are sensors in which every pixel is a processor. This architecture provides a massively parallel compute fabric at the point of light capture, enabling whole computer vision applications to be executed in pixel. This allows PPAs to excel in executing various high-speed, low-power applications. However, new methods must be created to exploit their unique architecture. This paper presents our implementation of point feature detection and tracking for pixel processor arrays, running up to 3000 frames per second upon a SCAMP-7 PPA, performing all computation within the pixel processors of the sensor itself. Our approach involves storing a binary point descriptor within every pixel processor. The PPA's architecture then allows us to test the response of every processor's descriptor in parallel. Response here meaning how strongly a descriptor matches the image content at its location. Here we see an example in which we put the same descriptor into every pixel processor. This produces the response map as shown on the right. We can see within this response map there are blobs of high response, such as that at the center of the number 4. These blobs indicate the locations of visual features which can be reliably tracked by this descriptor's response. By performing blob detection, we further highlight these areas, and then by performing thresholding, we are able to isolate the pixel processors of highest response within each one of these blobs. These are candidates for point features, which are detected using the response of this specific descriptor, and similarly which can be tracked using the response of this specific descriptor. Here we see another example putting a different descriptor into every pixel processor. This descriptor responds strongly to a different set of visual features than the last, thus producing high response blobs in 2 different locations. Repeating the same blob detection and thresholding process, we can see how this descriptor's response could be used to detect and track a different set of point features. As each pixel processor has its own local memory, there is actually no restriction on storing different descriptors within every pixel processor. Thus, if we have detected a point feature that can be tracked using a specific descriptor's response, we can simply keep that descriptor stored across all the pixel processors which are in close proximity to that point feature. We are then free to place another descriptor into the remaining pixel processors in order to search for additional features. We can iteratively repeat this process, detecting multiple point features using the responses of various different descriptors. This produces point features stored within the pixel processor array, each surrounded by a patch of pixel processors which hold the descriptor whose response was used to detect them. Then when computing the response map, each point feature will be surrounded by a patch of response from its own descriptor. And by finding the processor of highest response within each one of these patches, we can update each feature's location from one frame to the next. Thus we see how descriptor response is the mechanism by which our approach both detects and tracks point features. Importantly, our approach is performed entirely in pixel, meaning all computation is performed entirely within the pixel processors themselves. Not only is this very efficient, but it means there is no need to output a sensor image besides visualization. Instead, the sensor output can be massively reduced to only the descriptors and locations of tracked point features. This enables our approach to run at just over 3000 frames per second upon the SCAMP-7 PPA, consuming around 1 watt of power in the process. To the best of our knowledge, this is the first work to perform point feature detection and tracking entirely within the pixel processors of a PPA sensor, requiring no additional external computation to be performed. Our proposed descriptor in pixel approach, which places a descriptor within every pixel processor, enables us to use descriptor response as a mechanism for both detecting and tracking point features. The speed at which our approach can operate, along with its joint detection tracking methodology, gives significant advantages in terms of reliability and tracking quality over previous PPA works.